4 किलो ओम रजिस्टर, 1 किलो ओम रजिस्टर, दिस इज कनेक्टेड टू ग्राउंड। वहां एक कैपेसिटर लगा है 100 माइक्रोफैराड कैपेसिटर के अक्रॉस, 470 ओम रजिस्टर लगा हुआ है। नो, in the op-amp circuit shown, the Zener diode Z1 and Z2 clamp the output voltage V0 to plus 5 or what, minus 5 volt, plus 5 or minus 5 volt. The switch S is initially closed and is opened at time t equal to 0. तो यहां पर ना नेटवर्क के ट्रांजिएंट का कॉन्सेप्ट भी यूज हो रहा है, नेटवर्क के ट्रांजिएंट का कॉन्सेप्ट भी आपको यूज करना होगा। ओके, नाउ द टाइम t equal to t1 at which V0 changes its state is, right? What is the given here? In the op-amp circuit shown, Zener diodes Z1 and Z2 clamp the output voltage V0 to plus 5 or minus 5 volt. Okay, so here we have connected the diode Z1 and Z2 series opposing condition। देखो एक दोनों एक दूसरे को अपोज कर रहे हैं, and output, because of this output is limited. I will give you the explanation how it will limit the output. Then switch S is closed, initially it is closed, and that's why it will short circuit the capacitor and is opened at time t equal to 0. Now after 0 at t equal to t1 at which V0 changes its state from plus 10 to minus 10 or from minus 10 to plus 10. तो what is the initial value of the V0? ये आपको निकालना है। फिर कितने टाइम बाद आउटपुट में ट्रांजिशन होगा ये आपको निकालना है। जेनर डायोड का क्या रोल है मैं आपको वो समझाता हूं। यहां जो है वो प्लस 10 से माइनस 10 वेरी करेगा, यहां पर आपका आउटपुट वेरी करेगा फ्रॉम प्लस 5 टू माइनस 5। ओके, चलिए अब देखते हैं जरा। नो, ओके चलिए आ जाइए जरा। नाउ कई तो इस क्वेश्चन के उसको देखकर इतने सारे कंपोनेंट लगे हैं, डायोड भी लग गया, कैपेसिटर भी लग गया, बचा क्या है, राइट? नाउ देखो अब जरा वन बाय वन मैं एक्सप्लेन करता हूं इस क्वेश्चन को। फर्स्ट ऑफ ऑल, अगर आप ये पार्ट नहीं लगाते तो क्या होता? सपोज द 470 ओम इज नॉट कनेक्टेड, जेनर डायोड इज नॉट कनेक्टेड। उस केस में आपको एक सिंपल सा डायग्राम दिखाई देता है, ये ऐसा। दोनों को कंपेयर करना, ये होता माइनस, प्लस, देखो सीधा सीधा 4 किलो ओम 1 किलो ओम का एक फीडबैक है, और यहां जो आउटपुट होते हैं उसके दो लेवल होते हैं, प्लस 10 और माइनस 10 बिकॉज ऑफ द पॉजिटिव फीडबैक। ये हो गया 4 किलो ओम 1 किलो ओम R1 R2, राइट। और नॉर्मली यहां हम लोग क्या करते हैं, हम लोग एक R और C लगा देते हैं, ठीक। ये ऐसा हो जाता है डायग्राम। पहले तो आप इसको समझिए, देयर इज अ पॉजिटिव फीडबैक, पॉजिटिव फीडबैक, बिकॉज ऑफ दैट पॉजिटिव फीडबैक आउटपुट हैज टू लेवल, प्लस 10 और माइनस 10, and because of that we are getting the two different threshold levels, that is R2 upon R1 plus R2 into V0। लेकिन अब आपको आउटपुट नहीं चाहिए 10 और माइनस 10, तो लिमिट करना है। तो लिमिट किससे करोगे? विद द हेल्प ऑफ व्हाट? जेनर डायोड। तो जेनर डायोड को सीरीज अपोजिंग में आप लगा दीजिए। ये सीरीज अपोजिंग में जेनर डायोड लगा हुआ है। ये जेनर डायोड कैसे काम करता है, अब चलिए इसको समझते हैं। जेनर डायोड की वर्किंग कैसे होती है। नाउ फोकस ऑन दिस। ठीक है, जैसे आपने जेनर डायोड लगाया, एक रजिस्टर चाहिए यहां, और ये जेनर डायोड के सीरीज अपोजिंग में आपने जेनर डायोड लगा दिया। यहां जो वोल्टेज है 10 और माइनस 10 है, लेकिन यहां मुझे आउटपुट चाहिए 5 और -5, ये एक रजिस्टर, यहां वोल्टेज आएगा 10। अगर यहां पर 10 है तो क्या होगा, अगर 10 है देन because of this 10, what is the direction of the current? Like this. This is plus, minus, plus, minus, plus, minus. So what about this diode? This diode is forward bias. And what about this diode? It will allow the current when it is in breakdown region. इसको breakdown करवा दो. If it is a breakdown, तो इसके across breakdown voltage है VZ, और आप VZ को set कर दो 5 volt पर. VZ2 is equal to what? Let 5 volt. This is the second number diode. So it is a forward bias diode, ideal. It will act as short circuit. It is converted into a battery of voltage 5 volt. And what is the polarity? Plus minus. So what is the output voltage? 5 volt. The output voltage is 5 volt. ठीक है ना, ये short हो गया और इसके across आ गया 5 volt because it is the breakdown voltage like this. Short circuit. Here it is a 10 volt, here it is a R, and we are getting the output 5 volt only. So what is the output? Limited because of this Zener diode or clamping diode. So output is clamped at this value. Okay. So Mukhopadhyay, how are you? Very good evening. Sagnika. Okay. Now this is a 5 volt. So we can limit the output voltage up to what? 5 volt. So what is the role of this resistor? My dear friend, here it is a 10 volt, here it is a 5 volt. So extra drop will be across this resistor. Extra drop will be across this resistor. Because it is a 10 volt, it is a 5 volt. So what is the drop across the R? 5 volt. So ये है arrangement. देखो यहाँ पर. This is the clamping diodes. Here we are getting the plus 10 and minus 10. Here we are getting the plus 5 and minus 5. Now, second case. When VA is what? Minus 10. When it is minus 10, then it is minus 10. Now you want minus 5 here. Okay, no problem. This is resistor. One Zener diode. Second Zener diode. This is minus 10. What is the direction of the current? Like this. This is plus, minus, plus, minus, plus, minus. Now, this diode is forward bias. This diode is forward bias. This diode is what? Breakdown. This is plus, this is minus. And let the breakdown voltage is 5 volt. Watch this. Write down the KVL. It is a minus 5 volt. The output is limited to what? Minus 5 volt. When the input is 10 volt. This is the 10 volt and extra voltage will be across R. So these are called limiting diodes. First, the output is limited to plus 5 and minus 5. तो ये देखो ये छोटा सा concept है. It may be of 1 mark question. What is the range of the output voltage when the Zener diodes are connected? So we can connect this Zener diode through what? Symmetrical circuit, monostable multivibrator, astable multivibrator, right? This is a standard circuit. Now output is limited. Now at this point output is plus 5 or minus 5. Then what are the threshold level? पहला question. फिर से find the threshold levels. If the output is limited, then the threshold levels is that this is the R2, this is R1. And the voltage at this point 5 or minus 5. So upper threshold level or higher threshold level will become R2 upon R1 plus R2 into voltage at this point. What is the voltage at this point? 5. So this is nothing but what is the R2? 1 upon 4 plus 1, 5. 1 upon 5 into 5. So what is the voltage? 1 volt. This is the upper threshold level. Similarly, what is the lower threshold level? R2 upon R1 plus R2 into minus 5 when the output is minus 5. 1 upon 1 plus 4, it will become minus 1 volt. That will be the next question. What is the range of the voltage at a non-inverting terminal? Plus 1 and minus 1. When it is a plus 5 and minus 5. Okay. Now, अब आती तीसरी बात जो important है, what is the role of the capacitor in this diagram and when there will be the transition, right? Plus minus, yes, you have given the right answer, minus 1 and plus 1 volt. Now what is the role of the capacitor in this diagram? अब आ गया ये third point, थोड़ा question lengthy है, no problem. Now for t less than 0, exactly 0 negative, what about the capacitor? The switch off, switch is on, short circuited. So what is the voltage across this capacitor? 0. VC 0 negative is 0. What is the nature of the capacitor? Exactly at t equal to 0, we are going to open the switch. Capacitor does not allow sudden change of voltage. So capacitor क्या करेगा? Yes, thanks Pawan, how are you? PW fan club, okay. Now capacitor act as what? Short circuit. So capacitor does not allow sudden change of voltage. So what is the VC0 positive? It will remain 0. It acts as what? Short circuit. It acts as what? Short circuit. Right? Now what will be the initial output? You have to decide. What will be the initial output? You have to decide. तो आ जाते हैं next diagram में. Then now the switch is open. Now the switch is open. The switch is open. But initially capacitor acts as short circuit. Why? Because capacitor does not allow sudden change of voltage. When initially capacitor acts as short circuit, so what is the voltage at this point? This is 10 volt, so it will also become 10 volt. Now initially, because it is act as short circuit, exactly at t equal to 0 plus, then at this point output may be plus 5 or minus 5. So what is the voltage at this point? 1 or minus 1? My dear friend, this 10 volt is greater than 1 as well as minus 1. So negative terminal voltage is greater than positive terminal voltage. So when the negative terminal voltage is greater than positive, what is the value of the VA? Minus 10. And because of this Zener diodes, what is the output? Minus 5. What is the output? Minus 5. So initially the negative terminal voltage is 10 volt. That is greater than the positive terminal voltage. Therefore VA is equal to plus 10. Minus 10, sorry, and V out is minus 5. V out is minus 5 volt. Is it clear? At this point it is a minus 10 and because of this limiting it is a minus 5. And what is the voltage at this point? Plus 10 and negative terminal voltage is greater than positive terminal. Now if it is minus 5 because of the positive feedback, voltage at this point is minus 1. Voltage at this point is minus 1 and therefore positive terminal voltage is R2 by R1 plus R2 into V naught, that is 1 upon 1 plus 4 into minus 5, that is what? Minus 1. Lower threshold level. Okay. अब change करते हैं. Change. How we can change? Now the switch is open, therefore the capacitor voltage will change, capacitor will charge. Once the capacitor will charge, the current start decreasing. When the current start decreasing, drop across the resistor start decreasing, and that's why this voltage start what? Decreasing. Initially it is 10 volt, now the capacitor will charge and that's why this voltage start decreasing. Voltage at this terminal only. When this voltage will start decreasing and when it will become less than or equal to what? Minus 1 volt. Initially it is 10 volt. When it will become minus 1 volt, then there is a transition in the output. When the negative terminal will become less than the positive, there will be the transition. So we have to wait when the Vn decrease from 10 to what? Minus 1 volt. We have to find the time from 0 to T1 when Vn decrease from 10 volt to what? Minus 1 volt. Then there will be transition in the output. So first of all, how we can find the time taken by this point to decrease from 10 to minus 1 volt. Now what is the initial value at this point? 10 volt. What will be the final value when there is a capacitor? If you want to find the equation, what is the initial value, what is the final value, and what will be the time constant? Three things are required here. To watch this diagram again. Yes, now just to find the equation, लिखोगे Vn final value means at t equal to infinite minus final value minus initial value e raised to power minus t by tau. So what is the initial value at this point? 10. What is the final value? Final means at t equal to infinite, capacitor act as open circuit. This will act as open circuit. This is the resistor and this is the minus 10 volt. It is the minus 10 volt. What is the current enter into the op-amp? 0. Capacitor act as open circuit for DC. So what is the current through the resistor? 0. So this is minus 10. There is no drop. So what is the voltage at this point? Minus 10 volt. Voltage at this point is minus 10 volt at t equal to infinity. So what is the final value of the Vn? Minus 10. What is the initial value? Plus 10. What is the time constant? RC. R and C. So what is the time constant here? RC. What is the value of the R? 10 kilo ohm. 10 to the into 10 to the power 3 into 100 microfarad. 10 to the power minus 6. Right? देखिए कितना हो गया? 10 to the power 4, 10 to the power 6 into 10 to the power minus 6, that is 1 second. Please check my calculation. Calculation is your part. If you are finding some mistake in calculation, please write in comments box. I will correct it. Okay. 20 volt. No. I am not talking about the voltage across the capacitor. Just I am talking about the voltage across this point. This point. We want the voltage at this particular point, not across the capacitor. Why you are finding voltage across the capacitor? Okay. Now you can find the equation then. What is the equation here? It will become, now you have the final value and initial value. So what is the equation? Time constant is 1 second. What is the voltage across the V and T? Final value 10. Final value minus 10. Initial value 10. You will get minus 10 plus 20 e raised to power minus t. And that is the equation. This is the equation. Finished? Now, at a t equal to t1, it will become what? Minus 1. Why you are waiting for minus 1? When it will become minus 1, from 10 to what? Minus 1. It is going from 10 to minus 10. It will decrease from 10 to minus 10. But here it will become minus 1 at t equal to t1. When it will become minus 1, it will become less than what? Negative terminal voltage. When the Vn become less than negative terminal voltage, there is a transition from minus 5 to what? Plus 5. So at a t equal to t1, Vn is equal to what? Minus 1 volt. Put here minus 10 plus 20 e raised to power minus t1. Right? Now you have to find the t1. So it will become minus 10 plus minus 1, it will become 9. I think 9, na? 9 divided by 20 e raised to power minus t1. So you can find e raised to power t1 is equal to 20 by 9. So what is the t1? Log of 20 by 9 second. Log of 20 by 9 second. You can find with the help of calculator, natural log. ठीक है, देखो जरा कितना आंसर आ रहा है, वेरीफाई कर लेना, कैलकुलेशन कोई मिस्टेक होगी तो. दिस इज द कॉन्सेप्ट. 0.798 second. 0.798 second. And that is the answer for this question. Okay, this is the answer for this particular question, guys. Okay, so देखिए, what is the role of the Zener diode, what is the role of this potential divider circuit, limiting resistor, capacitor. Normally students are finding the voltage across this capacitor. No, not needed. Voltage at this point is needed. You can use this equation for what? Voltage across the capacitor, voltage across any point, voltage across this resistor. Okay, same thing. But what is the final value? You have to final value across Vn. What is the final value? Vn minus 10. What is the initial value at the Vn? Plus 10. What you want at Vn? Minus 1 volt. Time constant will remain same. In this way we can save our time. Yes. Okay. Sagnika, your answer is correct. I think you check your calculation and that concept is over. So देख रहे हो, एक question. One question will take around what 20 minutes to just to explain, but in exam hall you can solve this question within 2 minutes. You can solve this question by within 2 minutes, guys. Okay. Now, so it is a